Hi, this is Maggie. In this video, we're going to continue with our discussion of multiple inheritance in Python. If you haven't already watched the Introduction to Multiple Inheritance video, you should watch that first. I'll link it here, and I'll include a link in the description as well. I'm going to continue here with the same example from the last video. In this example, we have three classes, two base classes called calendar item and course, and the derived class section, which has both course and calendar item as its parent classes. For a very quick refresher, the first class is the calendar item class from Chapter 7 of Objects and Games with Python. A calendar item object is responsible for maintaining one entry in a calendar. It has a date, name, and calendar fields. The interesting method is activate, which is the method that is called when the date of the calendar item is the current date. So a calendar item can do something when its date comes up. The other class is even simpler and is called course. This class represents a college course, and to keep this example very focused, the course class has only two fields, which are both private, course name and description, and just accessor methods to return those values. The derived class is called section, representing a section of a course. Its unique fields are professor, location, and students, and it overrides and implements the activate method from calendar item, and it also has a register method to add a student to the section. All classes have an str method. The main program creates and prints an object of each of the base classes, and then it creates an instance of the derived class section and sends it the activate and register messages and prints the section instance. Here is the program running. Let's begin by looking at the output of just the section object's str method. I'll comment out the other lines of code that produce output and run the program again. We see the name and description of the course, which is part of the course class's str method. And then we see the name of the professor, the location, and the student list for the section instance. What we don't see is the date and the name from the calendar item str method. I'm going to scroll through the code slowly and see if you can come up with a guess or theory as to why. You can always pause the video to read the code, of course, or go grab it from the GitHub repo linked in the description. Okay, did you guess? Let me give you a little more information. Let's change the order of superclasses in the class definition for section. So instead of course calendar item, I'll write calendar item course. Now I'm going to run the program, but before I do, pause and predict the output. Is that what you predicted? Now we see the date and the value in the name field from the calendar item part of the object, but not the course name or description. This all has to do with something called the method resolution order. When we invoke the super method, Python determines which code it will actually bind to the call based on the method resolution order. When we have a hierarchy in which all classes have only one superclass, then it's easy. The method from the single superclass is invoked, or if it doesn't have the method, Python will look in its superclass, etc. But when there's multiple inheritance, it gets a little more complicated. Python will use the order of superclasses in the class header. So it will start with the first superclass. In our str example, that's the only code that's bound, because neither of the superclass str methods have calls to super. But suppose we put calls to super within the superclass str methods. We'll just do that the way we did it in section. We'll return the superclass call to str appended to a new line and then appended to the rest for both. And we run it. And that output might look a little weird. we're seeing the object class default str method being invoked because it is the superclass of all objects by default if we don't specify a superclass. So object is the superclass of calendar, item, and course. So let's look at the output and make sense of where the different lines are coming from. In main, we print our section object. This invokes the str method. The first part of the constructed return string is a call to super. Python will use the method resolution order to figure out what code that is. In this example, that's the str method of calendar item because we moved that to be the first parent class of section. Now the first part of that return string is the call to super. What's going to get called? It will be just like with the constructor. It will be the next superclass of section. That's course. So we go to that code, and the first line is a call to super. Now there's nothing left in our section hierarchy, so we go to course's parent class, which is object, and the default is to print this main.section object at and then the address. Then we return to where we were in course, and we append the course name and description. And that all gets returned to calendar item, where we append the date and the name, and then finally back to section, where we append professor, location, and the student list. If you think that's complicated, well, it is a little complicated, and this hierarchy is pretty small. I would suggest practicing with it and predicting the results, possibly running it in the debugger to figure out the method resolution order for different examples. You can also read about how the method resolution order is determined in greater detail at python.org. Now, another conflict that you might consider is a field name conflict. What if both calendar item and course had a name field rather than a name field and course name field? Let's change course's field name to simply name and see. I'm going to leave the initializer's parameter name as course name, or we will get into trouble in our keyword args dictionary. Okay, I think I've changed it everywhere. Now let's run the program and compare output. Notice that before, when we had a course name and a name field, the output was intro to OO programming for the course name and go to class for the name. Now they're both go to class. If there is a field with the same name in more than one parent class, then there is only one copy of that field in the object. This obviously could lead to serious problems because the methods of each class are expecting that field to be changed in well-defined ways by the other methods of the class, and not by the methods of a completely different class. I hope this video is helpful in demonstrating some of the pitfalls of multiple inheritance and how potential conflicts are resolved in Python. There are some exercises you can try in the description that work with this code. I urge you to work with them until they make perfect sense, read the method resolution guide, and practice with your own examples. When you can predict the method resolution order for different multiple inheritance structures, you're ready to move on.